Welcome back to This Explainer. Okay, today we are diving into a completely hidden, incredibly high-stakes world, chemical plant operations. It's basically a massive, sprawling industrial ecosystem where these highly specialized pros have to act as the brain, the brawn, and literally the detectives to keep the modern world running smoothly. Let's get right into it. Think about this for a second. What does it actually take to control a controlled explosion? Because, well, in a lot of ways, that's exactly what a chemical plant is. We're talking about a massive, high-pressure, incredibly volatile environment. And the operators, they are the ones right there on the front lines every single day managing these incredibly complex processes to prevent, catastrophic failures. So here's our facility map for today's explainer. We're going to break this down by looking at the chemical plant ecosystem, then the outside operators acting as the eyes and ears, followed by the control room or nerve center, then taming hazardous materials, and we'll wrap up with trend analysis and how operators act as industrial detectives.
All right, part one, the chemical plant ecosystem.
It really helps to think of these massive industrial facilities not just as like a cold grid of steel tanks and pipes, but almost like a living, breathing organism. Training protocols actually spell this out. Operators are considered to be the eyes and ears of industrial facilities. They are definitely not just button pushers standing on an assembly line. They are the crucial sensory organs that keep the whole ecosystem balanced, humming along efficiently, and absolutely, above all else, safe.
Moving on to part two, outside eyes and ears.
So there's a really clear line drawn here between the physical and the cognitive work. On one hand, you have the outside operator acting as the senses. They're physically out in the elements, monitoring the equipment, handling materials, and literally listening for weird noises or sniffing out leaks. Now, contrast that with the control room operator. They are the brain, sitting safely inside, hyper-focused on monitoring instruments, logging data, and tweaking process variables. It's totally symbiotic, two halves of the exact same whole.
So what are those senses actually doing out there on a daily basis? Well, they handle essential duties like conducting shift handovers, doing physical inspections of pumps, valves, and bearings, executing valve lineups, and pulling material samples. Oh, and here's a wild one. They even have to watch the sky. Seriously, observing the weather is crucial. If a sudden rainstorm rolls in, that cold water can drastically cool down the outside equipment. The outside operator has to catch that shift instantly so temperatures can be adjusted. If they miss it, an entire batch of product could be totally ruined.
Which brings us to part three, control room, the nerve center.
All right, so inside that nerve center, the brain is constantly glued to what we call process variables. These are things like temperature, pressure, or flow, basically measurable characteristics that can shift during a process. You guys probably know the textbook definition, but think about the real-world stakes for a second. In a highly volatile chemical environment, if the temperature drifts by even a single degree outside the safe limits, that could completely destroy a product, or even scarier, it could trigger a runaway reaction.
Managing stakes that high absolutely relies on establishing exact limits, keeping meticulous logs, and above all, constant crystal-clear communication. Take something as basic as starting up a massive industrial pump. That takes the brain inside and the senses outside communicating in perfect, synchronized harmony. If the control room fires up a pump before the outside operator has safely cleared that physical area, the consequences are completely disastrous. Every single action has to be a highly coordinated team effort.
Okay, part four. Taming hazardous materials. When we talk about taming materials, operators literally have to master 5 core chemical characteristics straight off their safety data sheets. We're talking toxicity, viscosity, which is just resistance to flow, volatility, temperature response, and pressure response. Knowing these 5 traits inside and out dictates absolutely everything they do. It tells them exactly how a specific chemical needs to be pumped, right down to the specific protective gear they have to wear just to survive being around it. Let's actually zoom in on one of the most dangerous traits up there, volatility. Basically, how easily a liquid becomes a vapor. Now, what's really interesting about this slide is how volatility instantly turns a simple, everyday liquid leak into a massive airborne explosion risk. Highly volatile liquids require pressurized tanks and vapor recovery systems. Why? Because if those invisible vapors manage to escape into the atmosphere, they don't just pollute the air. It means a single, tiny, stray spark could trigger an absolute catastrophe. And look, if a leak or spill does happen, hesitation is just not an option. Operators instantly deploy their chemical spill kits.
These are packed with the essentials: splash-resistant goggles, heavy-duty chemical-resistant gloves, plastic bags for hazardous waste, multi-chemical absorbents, and acid or caustic neutralizers like sodium bicarbonate. The rule of thumb here is simple. You don't go hunting for safety gear during an active spill, you grab the pre-packed kit and you contain the hazard immediately.
Now, I want to talk about a specific number: 15. This number is permanently drilled into the mind of every single chemical plant worker. 15 is the absolute minimum number of minutes an operator must spend under an emergency water shower if they get contaminated by a hazardous chemical. You step on the pedal, strip off the protective equipment, and you stay under that freezing water for a full 15 minutes to neutralize the chemicals. It's a pretty stark reminder of the intense physical risks these folks take on.
All right, let's look at Part 5, Trend Analysis, the Industrial Detective. Because surviving in a chemical plant isn't just about physical reactions and emergency showers, it requires intense, on-the-fly cognitive problem-solving. Operators are constantly watching charts to spot trends. On one side, we have expected trends. Think of these as normal cyclical changes, like when you're taking a batch process offline. But then you have unexpected trends. Now, a natural fluctuation will eventually just level itself out, right? But an unexpected trend, say a massive sudden pressure spike, is an unplanned, glaring warning of system failure. And that is exactly when the operator has to put on their detective hat.
The second they spot that unexpected trend, it triggers this brilliant, strict, four-step deductive reasoning process. Step 1, determine the meaning. Like, what is this chart actually telling me? Step 2, determine the cause. Why is it happening? Step 3, determine the actions. What do I need to do to fix it? But guys, Step 4 is absolutely crucial. Step 4 is determining the impact on other systems. An operator has to check the broader impact with the control room before they even think about touching a single valve. Because guess what? Fixing a pressure issue in one pipe could easily blow a seal in another system entirely.
Let's see how this actually plays out in a real-world scenario. Imagine this. If a pump bearing is running hot, then the whole system could fail unless the operator solves the puzzle. So our operator starts sleuthing. They check the oil. It's totally fine. They check the pump load. Completely normal. So they keep digging. They trace the cooling water all the way back to a heat exchanger, and boom, they find the root cause: low water flow in the shell side of that exchanger. By figuring out this puzzle and boosting the water flow, the operator cools down the bearing and literally saves the entire facility from an unplanned shutdown.
It is just an incredible display of skill and vigilance every single shift. So here is the final thought I want to leave you with today. The next time you use any modern product, whether it's medicine from your cabinet, fuel in your car, or the plastic in your phone, ask yourself, whose watchful eyes kept the plant from shutting down just to make it? It's this entirely invisible, high-stakes industrial world, and I really hope this explainer gave you a newfound appreciation for the brain, the brawn, and the amazing detective work of the operators keeping it all together. Thanks for hanging out with me today.